This video lesson looks into the determination of the sines, cosines, and tangents of specified angles. It shows you the method of determining these sines, these cosines, and tangents using tables. So tables like this one, or tables of a form similar to this. And we're just going to delve straight into examples to demonstrate the approach. So the first example question says, determine the sine of the following angles using the provided table of values. So the first angle is 30.5. So we're required to determine the sine of 30.5. I've been given this table. As you can see in the table, it's a table of sines of certain angles. And you can see in the first row, you can see numbers like 26, 27, 28, up to 31. And in the first column, below the sine, below sine here, you can see 0 0.0, 0 0.1, 0 0.2, 0 0.3. So here's how it works. If you wanted to determine the sine of, because this is a table of sines, you wanted to determine the sine of 26.1. You locate 26 and then you locate 0.1. So you go down from 26 and to the right from 0.1, and the value where they meet at, which is this 0.4399, is the sine of 26.1. So in our case, we have the angle 30.5, and here's the approach to use. So the angle 30.5 can be broken down into two parts, because 30.5 is the same thing as 30 plus 0.5. So what I've done is I've broken down 30.5 into a whole number part and a decimal part. So 30.5 same thing as 30 plus 0.5. So the decimal part and the whole number part is separated. The whole number part is 30, the decimal part is 0.5. Now what you do is you locate 30, the whole number part, you highlight the column, or you can just draw a line with a pencil and your ruler, just draw a line. And then you locate the decimal part, which is 0.5. As you can see, all these are 0 points. Well, all these numbers here on the left hand column have decimal points. They represent the decimal parts of the number you're looking for. The numbers on the first row here represent the whole number part of your number. Now I've just shown you an excerpt of a table of sines, just one that contains the value you're looking for. So we locate 30, the whole number part, in this top row. We highlight the column, as you can see it's highlighted, and we locate 0.5, the decimal part, in this left column, and we highlight the row it lies in. So I've done that in yellow, as you can see here, but I'm just going to draw a line. And where they intersect, the number at the position where they intersect is the sign you're looking for. So I'll just take that again. You locate the column for the whole number part, and you locate the row for the decimal part. Where they intersect, as you can see, this number, which is surrounded with this red border, is the sign you're looking for. So the sign of 30.5 is 0.5075. It's that easy. It's that easy. So we're going to move on to the next problem, which was determine the sine of 30 degrees. So now we've determined that the sine of 30.5, sine of 30.5. In fact, let's use this table here. So you locate the column of 30.5. That's this column here. So this is a column of 30.5. And you locate the row of 0.5. And you can see where they meet. They meet here, where we have 0.5075. So we know that the sine of 30.5 is 0.5075. So we're required to determine the sine of 30 degrees. And you know that 30 is the same thing as 30.0. So the whole number part, so I can say, well, 30.0 is the same thing as 30 plus 0.0. The whole number part is 30, and the decimal part is 0.0. So we're going to go to our table, locate 30, the whole number part, in this first row here, highlight the column, or in your case, you can draw a pencil to sort of highlight your column in a way, or mark your column with the whole number part, and you locate the row for the decimal part. Our decimal part is 0.0, and this is the row here, which hasn't been highlighted. Where they intersect lies the number, well, the sign we're looking for. So the sine of 30 plus 0.0, which is sine of 30.0, is 0.5. So simple answer is sine 30, or sine 30.0, which is the same thing, degrees, is 0.5, well, 000. to 4 decimal places. Here's another example question. This one says, evaluate the cosine of 45.7 degrees using table of values. And the table of values we're referring to are the tables of cosines, because we need to determine the cosine of an angle. Now, the angle is 45.7. 45.7 is the same thing as 45 plus 0.7. This is the whole number part, 45, and the decimal part is 0.7. So what do? We go to the tables, locate 45, the column containing 45, sort of highlight it, locate the row with 0.7, highlight that row. At the intersection, you'll find the cosine you're looking for. But we need to be using the table of cosines. So here is a table of cosines. You locate the whole number part, you highlight the column, you locate the decimal part, 0.7, highlight the row. They intersect at a position where the value you're looking for lies. So the cosine of 45.7 is 0.6984. It's that simple. It's that simple. Here's another example question. It says, determine the value of an angle theta. That's what the symbol means. The Greek letter theta, whose tangent is 0.4369 using table of values. And it also goes on to say that theta is less than or equal to 90 degrees, but 0 degrees is less than or equal to theta. I mean, what it says is theta is between 0 and 90 inclusive. And let me just show you. Let me just break this down. So here you see theta is less than or equal to 90 degrees. We know that our angle is less than or equal to 90 degrees. Theta is angle whose tangent is given here. And it also says that 0 degrees is less than or equal to theta. What does that mean? It means 0 is less than theta, which means theta is greater than or equal to 0. Remember, if you swap the left-hand side and right-hand side of an inequality, you need to reverse the symbol. So less than or equal to becomes greater than or equal to. So we know that theta is greater than or equal to 0, and theta is less than or equal to 90 degrees. So we know that theta lies between 0 and 90. Anyway, we don't know the angle, but we're given the tangent. So we know that the tangent of theta is equal to 0.4369. So how do you work out the angle? We're working in reverse now. Well, we know that we have a table of tangents here, as you can see. You locate the tangents are these values in this white field. So you locate the tangent value you're looking for, which is 0.4369, as you can see here. And we work backwards. Now, to determine the whole number part, you just look at the column in which this number lies. And that's the column with 23. So we know that our number has a whole number part of 23. To determine the decimal part of the number, you look at the row in which this tangent value lies. And that's the row with 0.6 as the decimal part. So 0.6 is the decimal part. So our number is 23 plus 0.6, which is 23.6. That means theta is 23.6 degrees. And that means the tangent of 23.6 degrees is 0.4369. And that's all. It's that easy. So here's my version of the solution. I've highlighted. I mean, first thing was to locate the tangent value, which was 0.4369. Then to determine the whole number part of the angle, you look at the column heading here, which is 23. And to determine the decimal part, you look at the row and you locate the associated decimal part. So just to emphasize, the way this table is structured is that this top row here contains whole number values like 20, 21, 22, 23, 24, 25. These represent whole number parts of some angles. So each column, so this column here is a column with the associated whole number parts 20. There's another column here, and the associated whole number part of the angle is 21. And here we have rows. This is a row here. For instance, look at this row. For this row, the decimal part is 0.1. So all we did was locate our tangent, then locate the whole number part of the angle and the decimal part of the angle, and just say, well, 23 plus 0.6 is our angle, which is 23.6, and that's all.